that's not grids or nesting. May as well take advantage of this moment. So, I was talking to a community member, got you cracking up, and he was saying it would be nice if there were more random maze generation tutorials. The technique I use has grids with nesting, and I thought it deserved its own tutorial before I get into it. So, let's get into this first. Okie doke. So in this demonstration I used 3 logic cubes. This little guy is a template, this medium one is visible, tinted gray, and also a template. Now everything in the big one runs once, so it should all run underneath this line. First, establish where you want the grid start position to be. That's the job of this little guy. Yeah, doing a great thing over there. Next, make a grid position copy. That way you can move around where the grid position is while still being able to keep track of where the original position. Now for the for each of. For each of 10. That just means all the child lines that run under it will run 10 times during that frame, just looping through. So if we say, if we create this visible logic cube at the position of the grid position we've created, then right afterwards taking the grid position's value x and incrementing it by 1. So if you're looking at it north, it'll move it to the right 1 meter. And then it'll loop through and do that 10 times. So the next time it'll create the logic cube, it'll be right to its side. And then it'll also increment the value for the next logic cube that'll be created. All the way until the for each of loop is exhausted. Tired at 0. And you get that cool row. Pretty neat. So variables are a lot of fun. They're pretty cool. So let's just change this 10 to a variable x. Pin it by pushing y. And then adjusting the value to bump it to 15 just for fun. Now when we create this logic cube, let's just turn it into a variable so we can play with it. So right after we create it, change its scale to 1. So 1 won't do anything because it's already at 100%, and that's the value of 1. So nothing there will be changed. The only difference here is since we bumped it to 15, there'll be 15 rows. Yeah. So it's not coincidence that the size 1 and the distance 1 are exactly the same. They didn't just land that way. The size of a logic cube is the size of what it is in meters, so that works perfect. So let's just slap a variable there instead called cell size, and I've pinned it as 0.1, so that's 10%. So, and that will also adjust how far each one will need to go. So same thing, but now smaller. Tiny little family of logic cubes. Row of 15. Now the fun part. For each of loop nesting. So we got our x, our row going. Now let's create our y. So let's do for each of variable y, pinning it and also making this 15 to stay true to a cube formation. After we indent it, we can create a line and drop it down. So the way it would work is it say for each of y1, then it'll go through and create this row. It'll go through that for each of loop x until it's exhausted. Once it's done making that row, we'll be at this line. And this line is readjusting where that position is. So now we're putting its value x back to its original position grid copy. So now it's back right at the start of where it was. Next, let's just bump it up 1. So now it's going to be a size, or just up 1, you know, I guess I already said it. And so now we're on for each of y2, and so that for each of y2 will be creating the row right above it, and that will keep going until it's exhausted. And since we set it to 15, it will be 15 by 15. So a tiny logic cube wall. Yeah. So going a little further, let's add the final dimension. We got x, y, and now let's do z. So we do for each of z, same thing, variable, pin it, and setting its value to 15, and then indenting, adding a new line, dropping it down so we don't lose track of where we are. Now you can kind of see a pattern. Now we're going to copy the last 2 things. So instead of readjusting its x, we're going to just readjust where its y was. So now that that's done, we can just increment where the z value is, because see, that's where we are right now, is the z. So it starts off with Z1, creates the wall by starting at for each of x, because for each of x and down creates the wall. When that is finished, and after it's done looping through, it reaches this line, or sorry, the recorrecting y line, and then after that it increments the z. So it pushes and makes a new wall behind it, and keeps making a wall behind that. So you end up with this perfect tiny cube of logic cubes. Pretty neat. Now I didn't really explain where to find your pin. So properties and my variables. So right here you can just instantly put in where your custom stuff. It's pretty cool. Yeah, bonus clip. Hey, check that out. Yeah. As of title update 14, we can kind of have code comments. Yeah. Pretty cool too. Thanks for watching.